Alright, in this section here we're going to be solving nonlinear systems of equations. And of course we can't read the whole thing here, I'll have to move that. But this says solve this nonlinear system for x and y. So once again we're solving for x and y in this system here. Write the solution I've got as an ordered pair is actually what it says. We can maybe move this over as an ordered pair. Okay. And we're going to write it as an ordered pair, x and y. We could graph these and see actually what the graph actually looks like and what we're really looking at. And I think what we're going to do before we actually solve this system, I'm going to go ahead and graph both of these and so you can see this geometrically. Alright, so this is the x squared here, the blue line, and the red is y is equal to 5x. So we're looking at where these two graphs intersect. Well, you can see that they intersect here at the origin, and I'm going to have to do some serious moving on this graph. And you can see that they intersect right here, and I'm not exactly sure what that is. This looks like 20 here, so anyway, we're going to find out what this point of intersection is. So you can always graph these things and definitely get an approximation if you had to go that route. But okay, let's go to the whiteboard and work this out. Alright, so we're going to have, we had y is equal to x squared and y is equal to 5x. Well, in order to solve the system, best thing for us to do is since both these y's are the same, right, we can just set these guys equal to each other. X squared is equal to 5x, and then I'm going to take the 5x over to the left hand side. Alright, so back when we were factoring polynomials and solving quadratic functions and all that kind of stuff, this is what we were leading up to, really. Alright, of course there will be some application problems that come along with all this stuff. But here we are. Let's go ahead and pull out an x, and then we have x minus 5. So we can set both these factors equal to each other, and that's an easy one there. X is equal to 0 and x minus 5 is equal to 0. We solved for x in this problem and we got x is equal to 5. So it turns out we have two x values. Now remember where the graph crossed, so we had our graph like this, and it's where the graph crossed the origin here. Okay, let me do this in a different color. And it did something like this. So the graph crossed here at the origin. So the x is 0, and to figure out what y is, we go into either one of these equations. It doesn't matter which one we use. You can use this equation or this one here. To find out what y is, you would just plug 0 in. Right? You would just plug 0 in. So 5 times 0, and then of course we get 0 out. So that's one of our ordered pairs. Then we would look at the other x value, which is x is equal to 5. So this must have been 5 here on the x-axis. And to find out what our y value, our second coordinate, is going to be, we would just plug 5 into, it doesn't matter which one we plug this into. So 5 squared is 25, or 5 times 5 is 25, right? So there's our two solutions, and that's where the two graphs intersect. Okay, so let's look at another one. Actually, I think what I was going to do is come here, click on answer, and we get 0, 0 and 525 as our two ordered pairs. Alright, let's look at number 2 here. Alright, so you can see here we have y is equal to 49x squared and y is equal to negative 98x minus 40. So we're going to do this the same way. We're going to set them both equal to each other, and then we're going to solve for x. Now in this particular problem here, this is going to be a little bit more difficult, but if you followed some previous sections, you should know how to work this problem. Alright, so let me get this written out here. We have y is equal to 49x squared, and then our other equation is y is equal to negative 98x minus 40. Alright, so what we're going to do here is I'm going to go ahead and set these both equal to each other. So we have 49 x squared is equal to negative 98x minus 40. Okay. Then I'm going to go ahead and take these over to the left hand side, and you'll see why here in just a minute. Equals 0. Alright, now we're going to want to factor this. You can use the quadratic equation if you want, but I'm going to try to save us a little time. I'm pretty sure that these coefficients here are 7, because 7 times 7 is 49. So we're going to try this out. We're going to need, let's see, 7 times a number plus 7 times another number is going to give us 98. And we multiply them together, these two numbers here, we got to get 40. 5. Alright, let me work this out here. Okay, now the question is what needs to go here. I'm going to try a 4 and a 10. So this has to be positive. And that has to see 70. 7 times 10 is 70, and 4 times 7 is 28. And 70 is 7, 8, 9. So that'd be 98. Okay. So this is going to be a plus and a plus. We set this equal to 0, and we set both of these factors equal to 0. And therefore, x is equal to negative 4 over 7, and then I do the other one, 7x plus 10 is equal to 0, and therefore x is equal to negative 10 over 7. So we have two x values, and we're going to take each one of those and plug those in to either one of these. It doesn't matter which one we plug these into, and I think I'm going to plug them into this one here. Okay, it doesn't matter, but I'm going to plug it into the top one up here to get our y's. So 49x squared. So we're going to have y is equal to 49, and we'll do this one here, negative 4 over 7 squared. And so this becomes 49 times, that's going to be 16 over 49, and that's going to reduce down to, because 7 squared is 49, so that's going to end up reducing down to, it looks like 16. Alright, so we're going to have negative 4/7, comma 16, and then we're going to do the other one, and let's see what we get. This is negative 10 over 7, so negative 10 over 7 squared, and so that gives us 49 times 100 over 49. Of course, these 49s cancel out, and we're left with 100. So our other solution is going to be negative 10 over 7 comma 100. So these are our solutions to our system. Okay, and let's go back to the web page and see if that's what the web page calculated. And of course, that's what the script shows. So, and I'm definitely going to be going by this is the answer. All right. I think I'm going to let number 3. I think I give enough examples. I've only got 3 examples in this section on nonlinear systems. Like I said, this is supposed to be just intermediate algebra, but the reason we're learning the intermediate steps is so we can solve these type of problems, and of course we want applied problems, you know, so we can construct these kind of things and then solve for x. That's really the whole idea here. Alright, what we're getting at. But okay, good luck, and I think I'm just going to end it with that. You might want to come up here though and check out number 3.